everyone. In the last lesson, we learned about direct variation. And in this lesson, we're going to learn about inverse variation. And most of the rational functions that we're going to be learning about in this unit is going to have some sort of relationship with inverse variation functions. Before we get started though, I would like you guys to please complete this really quick warm-up where I simply want you to solve for y. So the problems that I want you to solve for y are the following. I have x times y is equal to 7. The second one I have is x plus y is equal to 3. And the third one is y over 4 is equal to x. I want you to get y alone in each one of these problems because each one of these problems are a problem that you might see on your test coming up in the next few lessons. So please make sure that you pause the video and try each problem genuinely on your own. And when you have an answer, please restart the video and we'll see how well you did. All right, so the directions say solve for y. So that means that you need to get y alone. And what we have in example 1 is we have x times y. And in order to get y alone, that means that we need to divide both sides by x. So we have y is equal to 7 over x. For our next problem, I'm going to get rid of the addition of x by subtracting it on both sides. So we end up with y is equal to negative x plus 3. And finally, in order to get y alone, I'm going to get rid of the division of 4 by multiplying both sides by 4. And we end up with y is equal to 4 times x. So what you might see on your test is this. You might see equations like you see here. X times y equals 7, x plus y equals 3, and y over 4 equals x. And they're going to ask you which one of these is a direct variation, which one is an inverse variation, and which one is neither. And in our first problem, whenever you are dividing by a variable, dividing by x, we have y equals 7 divided by x. This is an example of an inverse variation. So in direct variation, it was always a number times x, but if we're ever dividing by x, we call that inverse variation. And that's what this lesson is all about today. The next problem is a neither, y equals negative x plus 3. What makes this neither is, although it's linear, it has a b value that is not 0. So that means that it's not a direct variation. It's not an inverse variation either because you're not dividing by x. And finally, y equals 4x, this is a direct variation equation. And what makes it a direct variation equation is the fact that it's in the form of y equals a times x. Your b value is 0, so that's what makes it a direct variation. So our learning target for today is for you to be able to say, I can determine if an equation or a table represents a direct variation or an inverse variation or neither. That's also something that you're going to see. It might be one or the other, or it could be neither. The other target is I want you to be able to say, I can write and graph an inverse variation given an ordered pair. So you're going to receive one ordered pair, just like you did with direct variation. And I want you to be able to say, I can write and evaluate an inverse variation given a real-world context. So there's going to be a phrase that you're going to be looking for in real-world contextual questions that's going to tell you that it's an inverse variation. So what is an inverse variation? An inverse variation requires you to have an x and a y value or two variables that are related as follows. You're going to see an equation that's going to be written in the form of y equals a divided by x. And the way that you come up with your a value, so in direct variation, it was a y divided by x. So with inverse, it's going to be the opposite. A is going to be equal to x times y. So direct variation, just to make sure that we're all on the same page, direct variation, you would see an equation that is y equals a times x. You're going to see that times x. X will be in the numerator. And we know that a would be equal to y divided by x. Now we're learning about inverse variation. And what's going to change is that instead of it being y equals a times x, we now have y equals a divided by x. And our a value, instead of y divided by x, we're going to multiply them, x times y. Think about it. If we wanted to get a alone, we would multiply both sides by x to get rid of the division of x to get a alone. And that's why a is equal to x times y. Next, the constant a is called the constant of variation, just like we saw with direct variation. And the language that you're going to see in story problems is instead of y varies directly with x, instead, in story problems, you guys are going to see y is said to vary inversely with x. So it's going to be an inverse variation. So you're going to see inversely in your problems. So in example number 1, we want to show and state whether x and y show a direct variation, an inverse variation, or neither. So for each problem, what you want to do is you want to get y alone. And from there, we're going to identify what type of equation we have. So for letter A, I'm going to start off by adding 3x to both sides to get y alone. And we end up with y is equal to 3x. This is a direct variation, and that is because we are multiplying a number times x. So this is direct variation. For the next problem, I need to get y alone, so what I'm going to do is I'm going to start off by multiplying both sides by y to get it out of the denominator. So I now have x times y is equal to 3. I'm going to divide both sides by x, and I end up with y is equal to 3 divided by x. Because we are dividing by x, that's what makes it an inverse variation. And finally, I'm going to subtract x on both sides, and we have y is equal to negative x plus 5. This is a neither. And what makes it a neither is that even though it's linear, our b value is not 0, so therefore it is a neither. We don't have a special word for it other than it's a linear function. Now let's go ahead and look at letter D. In order to check whether or not something is direct or inverse, you have to think about how do you get your a value. So to check if it's direct or inverse, we have ourselves some rules. For direct, we need to see is every y value divided by every x value with respect to the ordered pairs. So you match up your ordered pairs. Are they equal to the same number? If they are equal to the same number, then we have ourselves a table that represents the direct variation. And that same number is going to represent your a value, and we would write our equation in the form of y equals a times x. If they are not the same number, then we check for inverse. Inverse means that we're going to see is every x times y equal to the same number. If every product of x times y equals the same number, then that means it's inverse, and we would write that as y equals a divided by x. If neither work, then we call it a neither. So let's go ahead and check this out. I'm going to start with direct, and I'm going to go 21 divided by 4. Is that equal to 14 divided by 6? Well, 21 divided by 4, they have nothing to eliminate, so we just leave it like that. And 14 over 6, well, that's going to be equivalent to 7 over 3. And 21 over 4 is not equal to 7 over 3, so we know this is not direct. So now we're going to check inverse. So I'm going to check, is 4 times 21? We know that that number is equal to 84. And 6 times 14, if you were to use your calculator, you find that that is equal to 84. And 8 times 10.5, that equals 84. And 8.4 times 10, that is equal to 84. And 12 times 7, that's equal to 84. You have to check every single product to verify that it is indeed, that all of the products are indeed equal to the same number. And in this case, they all equal 84. So that means that this is an inverse variation. And where do I want to write that? I'll write it right up here. This is an inverse variation where our a value is equal to 84. So our equation is going to be y equals 84 divided by x. And that is our function. This is an inverse variation, and we write it as y equals 84 divided by x. All right, we only have a couple more examples and then we are finished for today. Let's go ahead and flip the page. For example number 2, it says the variables x and y vary inversely. So x and y vary inversely, and y is equal to 15 and x is equal to 1/3. We want to write an equation that relates x and y, and then we want to find y when x is equal to -10. So x and y varies inversely. So that means that we're going to be working with the equation y is equal to a divided by x, and that's where a is equal to x times y. So we first need to identify our a value. My a value is going to be x, which is 1/3, times my y value, which is 15. And 15 times 1/3, that's 15 divided by 3, which is 5. So a equals 5. So my equation is going to be y equals 5 divided by x. Now I'm going to let x equal -10, and I'm going to find what y is. So y will equal 5 divided by -10, which is -1/2. And that is my y value whenever x is equal to -10. So now, whenever you're checking for inverse variation, there's some things that you guys need to just know about inverse variation. First of all, the general equation looks like y equals a divided by x. And those are for inverse variation equations. And please know that if you see an equation where you have a number is equal to x times y, that's also considered an inverse variation. So as long as you see one or the other, you automatically can assume that you have an inverse variation relationship. The preferred equation is that's written, that I want you guys to write it as, is y equals a divided by x. So this tells you that as for a set of data pairs, call them x and y, for any type of data pairs that we have, it'll show an inverse variation if the products are constant or approximately constant. So what that means is that if you multiply them together and they're pretty close to the exact same number, if you rounded them, they would end up equaling the same value. Then we would consider that to be an inverse variation. So approximately means that it's going to be very close. And if you're not sure of what's considered very close, make sure that you have a conversation with me about it, especially when you get to those problems in your homework. So this is our last example. It says moving cartons are manufactured in a variety of sizes and shapes to accommodate the variety of objects that need to be packed. The table compares the area, which is the area of the bottom rectangular carton in square inches, with the height for 4 available cartons that have the same volume. We want to write an equation relating A and H. So since we want to write an equation that relates A with H, notice that A is in the X position and H is in the Y position. So because we always read our tables the same exact way each time, our equation is going to be written in the form of H is equal to our A value divided by capital A. So our little a is our constant of variation. So what we need to do is identify what our constant of variation is. So by multiplying. So what we're going to do is we're going to multiply 50 times 24 just to verify. 50 times 24, that is equal to 1,200, and 100 times 12 is equal to 1,200, and 120 times 10 is equal to 1,200, and 150 times 8 is equal to 1,200. So because all of the products equal the same value, we can say that little a has to equal 1,200. So our equation is going to be H equals 1,200 divided by capital A. Now, if all of your products did not equal the same number, then what you would want to do is divide. You would want to divide all of your H values by your A values. You want to divide all of your Y values by your X values to see if it's a direct variation. And if it didn't work, then that means that this is a neither situation, so you would not continue with the problem. So for letter B, it says predict the height of the carton with the same volume as those in the table that has a base area of 75 square inches. So what that means is that we're going to let A equal 75 square inches. And I want to find what the height is. So we want to predict the height. So I'm going to say H is equal to 1200 divided by 75. And so when you go 1200 divided by 75, you end up with 16, and our height is just going to be 16 inches. And that is simply your answer, and that is the end of today's video. If you have any questions over anything, please feel free to email me. Otherwise, I hope you have a wonderful day.